Now let's talk about the similarity-based recommended systems, means similarity-based algorithms. So there are two types of similarity-based. We have seen that in our recommendation matrix that we have built in our previous lectures. Since there we needed two items. One is users, two kind of things. One is users, and the second one is items. Okay. So for these things, for these two regions, there are only two types of similarity. There have two types of similarity. The first one is item similarity. Item similarity, and the second one is the user similarity. User similarity. We have these two types of similarity. So we will see what is advantage and what is the disadvantage for each similarity algorithms. We will see in this video. So, but the item similarity are the most popular one. Means many e-commerce website, as well as if you consider YouTube, or as well if you consider Netflix, such kind of, it's the mostly popular one. This item similarity is the most popular similarity algorithm. Most popular one. Okay. Now let's discuss one by one. So first we will see user similarity. After that we will see the item. First see the user similarity. User similarity. What is actually these things? How to calculate it, these things? So if you remember, the matrix that we got, this kind of matrix. These are the recommendations matrix. In general, we call it A, this one, and in a each row actually is denoted by the each users. U1, U2, U3, to somewhere it is UI, and somewhere it is up to user N. Now in a column, we represented by item 1, item 2, item 3, item Z. So let's take its item M. We have, so for each item and correspond for each user and corresponding to each item, this value of this here is, suppose let's take Aij, this user and corresponding for this item Aij. Aij, this is called the Aij. Now the first job that we have to do, we are going to discuss here the user similarity matrix. So first we have to pick up any user. Okay, pick up, suppose let's now for some time let's just delete this. Now suppose we will pick this user I. We'll picked up this user I. Okay. Okay, we will picked up this user I. Now for this user I, the each component, there have m components for each items. So this each one I1 means there have m components. There are m components. So if you just write this vector individually, so this right, if you put this vector here and write it individually, so here ui is actually, this vector will be like that. For this vector there have m components, and each component is responsible for each item. This component is responsible for I1, this component is responsible for I2, item 2, this is responsible for item 4, such like that. This is responsible for item M. So this is the sample representations of a vector representations of each users corresponding to the each item. So first thing, so this vector is called a user vector. This vector is actually called a user vector. This vector actually called the user vector. Okay, so the user vector that we got, this ui, this is the sample a user vector. User vector that we got here, it's the vector is a mainly sparse vector. This vector is sparse vector because a user may not have seen any, means all the items, or just it's instead of million items they are interested in only few items. Okay, they have seen only few items, or they have watched some few movies. Okay, so because of these reasons, this vector, this user vector is a very sparse vector. This vector is a very sparse vector. Okay, since this sparse vector already we will see in the back of what vector. When we transform a text to a vector, then we will see this kind of sparse vectors also we got there. So it's similar of back of what technique, if you remember. Okay, we'll say these things. Now don't be confused. Now the questions is, we can, for individuals users, we can easily find this user vector. Now the questions, how to find the similarity between these users. Okay, because since this is a sparse vector for each user, since ui is a sparse vector, typically in general. So since it is a sparse vector, in general we will use the cosine similarity. It's better because to handle sparse vector, it's better to use the cosine similarity. It can easily handle all the calculation. Okay, so if you, actually this depends on our problems, in which problem we have. So according to our problem, we have to use our similarity vector, similarity methods. Which similarity methods we have to use. But in general, since it is a sparse vector, we have used the cosine technique, cosine similarity technique. In general, we use cosine similarity. Okay, so now how to calculate this similarity between the two vectors? Two means I'm talking about two different vectors, different user vectors. So the similarity between two different vectors, ui and uj, where ui totally different from the uj. I will compute this. We will simply compute by using the cosines of ui comma uj. Okay, cosine of between this. Already we have seen in the means supervised learning module in series. You will see how to compute this cosine from cosine similarity value. This is simple the dot product of ui and uj. This is simple the dot product of ui transpose uj divided by its norm value, ui norm into uj norm. Okay, we will already see in the logistic, I think logistic regressions chapter, we have discussed the cosine similarity. Okay, so easily you can find this value. Now after finding this value, we have to construct the cosine similarity, user similarity base matrix. If you just remember this thing. So now the task is, we have to compute the similarity matrix between each users. Okay, so easily we can, by simple using this cosine similarity formula, we can easily so let's denote it by something, some value. We have using this similarity, and we have used this for users u, and we have calculated this for the two different users I and j. Simple, these notations are used for, this is the user similarity between the two users I and j. this by simply using this. Now the task is we have to construct the matrix. The similarity matrix are denoted by SU. It's simple. It's simple by using this matrix, this type of matrix. SU I okay, where I is running from 1 to up to n, and the j is will be from 1 to up to m. Okay, this is the representation. Means this the dimension. Sorry, j is also for n. It's my bad because there have only n users n. So this matrix must be a square matrix, n cross n dimensional matrix. This matrix. Okay, this matrix actually called the user similarity matrix. User similarity matrix. Okay, and the component of this matrix, if we write this matrix in that format, okay, so here the value means that this is the user 1, user 2. Well, let's take user j, it is up to user n. For user 1, user 2, user I, user n, and this value uij, this value is uij. It's actually represented the similarity between ui is to the ui and uj. This value is called the similarity value between the user ui to the user uj. Okay, these things, really, these metrics are talking about. I think you got the point. Now the task is you can easily build these matrix. Now the task is that we have to do. The task is here. Now the task is we have to recommend new items for a customer. That's the come. Actually, that's the job is we have to recommend some items to the users. That's the at the end of the day we have to do doing these jobs. So the job is first. Now the job is recommended a new items to the users. That's the job that we have to do. Okay, suppose let we have recommend some new items to the user. It's better if we taken some examples. Suppose let's take we have take some examples. U10 example, U10 we have to recommend some items to some users U10. Okay, now how we'll doing this thing, how we'll do these things. Okay, so first thing for U10, first thing that we have to do, taking a different for the user U10, we have to find what are the similar users for these users. How will find this? So suppose let's it's somewhere here it's the user 10, it's somewhere here it's the user 10. Okay, now if you looked up this similarity value, based on this similarity value we can pick up the most similar users for this user U10. Okay, using this value. So from this value, suppose let we got the user 1, let user 2, user 7 are the most similar user on this user. Let so these are the three most similar user to the user U10. Okay, these are the three most similar users. Let. Okay. Now, after finding the similar user, the next job that we have to do, we have to pick the item that's liked by each users. These users. After finding this, we have to pick the item. Pick the items. Pick the items that are liked by. That are liked by this age users, that are liked by the user 1, user 2 and user 7. That's the okay, that are mostly liked by that. Okay, and the one thing, so there may have some common items that's also liked by user 10. Pick the items that are liked by age users u1, u2, u3 and that are not, that's things always you have to mind, that are not yet watched by the U10. Means we have to pick up those items that are liked by the users, age similar users of the U10, means user 1, user 2, user 7. And the conditions is that items must not be yet watched or must not be yet bought or must not be yet seen by the user U10. That's the job we have to do. Okay, I think you got it. So now from these items, we have to recommend it, these items to that user. Now the next step is we have to recommend it. Recommended them to the user U10. Okay, that's the job that we have to do. So first job is we have to find the based on this matrix, we have to find the similarity matrix. Similarity matrix is, since we have seen it is a sparse vector, by simply using the quotient similarity we will calculate the similarity. Then after calculating the similarity between each users, we have to construct the similarity matrix. You can easily doing this, that's not a hard. Okay, now our main task is to recommend new items. How will we have to first find the, first we have to choose the customer, target customer. What is our target customer? So on the target customer we have to find the who are the similar customer on that customer. Okay, here as an example we have taken the u1, u2 and u3 are the similar customer, and now we have to find the products that are the like by that similar customer, and the conditions is that products are all not yet watched or not yet bought or not yet seen by this user, the target user. Now based on these items we have to recommend these items to the user. That's the simple job that we have to do. Okay, but they have some problem. But the problem is here, but they have some problem. But they have some problems with user similarity. Now let's see what is the problem behind it. What is the problem of the user similarity? Okay, the main first problem is this users preferences changes over time. This users users preferences changes over time. It's a natural matter. So our preferences is always changes, it's time to time. Okay, changes over time. Let's see. Suppose I'm a user of YouTube. Suppose let's consider a YouTube example. Consider these YouTube examples. Suppose let's take, I am watching some video because I need watch some things, and suppose let's take I am interested to watch some mobile phone. So based on this, actually we have to interest to buy the mobile phone now. So now today Suppose let's take today I am watching some review, mobile review video. Mobile review video on it. So after going it, I'm not interested on such kind of review kind of mobile review kind of video because I have already bought. So on to after sometimes these changes have changed. So after sometimes suppose let's take after 1 week when we have already bought a video already sorry I have already bought a mobile. After I am interested to some listen some beautiful music. So listen music, listen music. Okay, so this time to time matter. Suppose let's take some time one have my choice and some after some time two it's my choice. So it's actually change to changes. Actually the choice is depends on our needed. When actually our need is also change time to time. So these things our users preference also change time over to time. So because of that reasons we cannot we the user choices is find the actual similar type of customers, similar type of users actually very hard task. So reasons because of this reason because, because of these reasons to find the similar users is a hard task to find them. Similar users a very hard task is a very hard task reason. Because of these reasons user preferences have changed over time. To find a similar users actually it's a very hard task. Okay, when we'll discuss the case study we'll see these things how these preferences has changed time to time. Okay, we'll see. Now because of this problem we generally we avoid this user similarity concept. Now let's discuss the item similarity. What is the item similarity and why this item similarity is most popular one among all the similarity based recommender system. Now let's see item similarity. Let's see it step by step. Item similarity. Okay, so the first job the same things that we have to find the item similarity matrix that we have find for the users. We have to doing the same job. We have to doing the same job here. So let's recap this thing. The matrix that we got is here. Like this is for user 1, user 2, user 3, somewhere up to user n. This is for the item 1, item 2, item 3, somewhere item m. Okay, these are the things that we have to do. Okay, now instead of using the user or row, in previous case we have used the row, so but here we have taken the column vector. Suppose let I am considering here the item j. I am considering here the item j. Now we have picked up any column for the item similarity, any column we have to pick up. Suppose let's for item j I am picked up this column, this column matrix A. This actual matrix is called the A matrix. So the item matrix item j that we have picked here, this is responsible for first count user 1, this is responsible user 2, user 3, like that user n. Okay, these things are the responsible for age users. Okay, so after picked up the items vector, this item j, this ij actually called the is ij as uj, what I'm calling ui actually called a user vector, user vectors. Ui is called the user vector, and similarly ij is called the item vector. This one is item vector. Then for this item vectors, this is must be a sparse vector because each items can, it's not actually possible. Each items is liked by each users. Some little bit users have liked some few items. Okay, so this must be a sparse vector. So since it is a sparse vector, we will similarly here we have also used the cosine similarity value. Similarly, sparse vector, we use cosine similarity. Typically we use, but it depends on the situation to situation. Cosine similarity. In general, we will use this thing, cosine similarity. Okay, that's the same things also we have to use here. So the similarity value here, the item similarity between the two items. Suppose let's take item I and the item J. These items we have, for example, using the cosine similarity. So cosine similarity, we got it for item I and item J. It's the same formula we have to use here. AI transpose dot product of AI and IJ and its norm vector. Item I into item J. That same concepts also applicable here. And these vectors, this similarity value, these two, this is called the, these vectors actually called the where I have it defined here. Here I have defined the SI similarity value. These things as defined by similarity value between the items for these reasons I and two defined items I and ij. So first concept is here I not equals to ij. Okay, that's the first. So by finding, after finding the similarity value between each item, we can easily construct the similarity value between the each similarity matrix between each item. So this matrix is now will be as ij, and its dimension the similarly how much item here we have m items, so this value will be must be m cross m, but here the value is n cross n for users, but for here it is m cross m. Okay, I think you got the point. The same things also applicable over, but the most popular, why these things are actually most popular, the most popular because the rating on a given product or item, it's do not change significantly over time after initial period. Means suppose, so after some period we have launched some product. Okay, after, if we see that after some period, after some initial period, if the rating has significantly constant, don't change much, so in such scenario we can consider this product as a great product, means valuable product we can consider. The using the similarity is like that, the value of the product it's changed, but there have also some product that's value is not changed much because its demand is not changed so much. Okay, so but the choice of the users are changed frequently, but the value of the items is not changed so much. So just the popularity, most popular, the reason behind it is the most popular. So these are the reasons, because the rating on a first rating on a a given product rating on a given product or item change significantly. If not, rating on a given product or item does not change significantly. If it does not change significantly over time, but time after the initial period. After the initial period, then we can consider it's the most valuable product. Okay? Then we can consider it's considered as the most valuable product. Okay, that's the thing that we have to do here. Suppose let's try to understand to a movie. I think it's better if you just take an example. It is better for. Suppose let's do an example. Three Idiots. I'm using the Three Idiots. I think in India, it's mainly in India. It's a very popular movie. ED. Okay, I think spelling is okay. Idiots. Okay. If I'm doing some mistake, please correct it. Don't mind. Suppose let's take this example, Three Idiots movie. So till now, this movie is a very popular one. Till now, its fan base is not so small. So is after means I think it's released 2012 or 2011 something sometimes. Okay, so when we to release this, we have seen that its ratings are totally increased. It increased. If it suppose let's I try to understand through this example. It's the y-axis we have taken the value and it's the year. Okay. So if we just plot this, suppose 2011, I think it's released 11, 2012, something 2013, like that. Here now we have reached 2021. So if you see, so after some period, so first it's the okay, it's increasing, its rating is increased, and after some periods its rating is still constant. If it is fine, is significantly constant. Okay, it's increased and after some time it's stabilized. This type of stabilized. So if this one is 5 rating, 5 value, if we 5, it is the for 1. So after some initial period, we have seen that till now, this movie is a most valuable movie. Till now, it is a valuable one because its demand till now it's not decreased. But suppose let I have taken another movie. I have taken another. Suppose let's take I'm not remembered in the movie name. Suppose I am taking here some movie XYZ. I have taken some movie. The same graph also plot for this. Okay. Suppose I'm taking another movie XYZ. I am using the red color here XYZ. Sorry, the pink color XYZ to denote the XYZ movie. Okay, if you just plot this kind of plot, suppose the same movie also released in 2011, but after some time it's increased. But after some initial period, its demands is like that. If these situations happened, if these situations happened, so this is for this XYZ movie, and this yellow color is for this 3 Idiots movie. So then we can conclude that. It's not a valuable product. It is not a valuable product. Okay. Because after some initial period, its demand has already decreased. Okay, there are many examples in our real world. And so because of these reasons, because the most popular this item similarity, because the rating on a given product or items is do not change significantly over time after some initial product, then we can consider this product. Okay, because of these reasons, we will use this item similarity. Okay, now the questions that is how to find how to recommend it is how this task has been done. So in the task, for user you just recommended new item to the new user, recommended new item to the new users. The same task is also applicable here, but how to doing this job, how to doing the same task here. So the tasks, how to handle these tasks from this user similarity. So the for here first, suppose the same example. So we have to recommend something, some new item to the user. Let then user U10 I have example taken here, and the first here we have find the similar users that based on this matrix. But here instead of finding the similar user, we have to find the item that have mostly liked by this user, the item. So by simply using this matrix, A matrix, we can easily find the same thing. Because suppose let's take here somewhere here. So from this matrix, from this row value, we can find the items that these users has mostly liked. Okay, the first job that you have to do, find the items that is mostly liked by user. Okay, so suppose let's take we got these items. Suppose we got the item 1, item 3, and item 7. We got this item. Now after finding this item, we have to choose the similar item of each items. Suppose let's take now to find the similar item, we have to use this matrix. This similarity value we have to use it. So let now with the similar product for this item 1 is like that. This is the similar product of the I1, similar products of the I1. Suppose later these are the similar product, the I3, and suppose these are the similar product for I7. These are the I3, and these things are the similar product of the I7. I7. Suppose because they have chance many items are the similar to this item, we can easily find this by simple this SI matrix. We can easily find this job by simply using the SI matrix. We can easily find. Now suppose there have some common product. Suppose there have some common products among all the items. There have some common products I4. There have also some common product I4. It may be possible. So here have. Now, based on this, suppose let's say the same common product. So here, let I4 is a common product for H similar items. For H similar items, let these things happen. If these are the common products, because U10, the user U10, and find the we have from the user U10, we have find the products that are the liked by U10, mostly liked by, and these items are most similar of this item. Okay, and these are the common product of this item. Obviously it is the common product. So now based on these results, we recommended I4. We recommended I4 to this user. We recommend recommended RECOMM recommended. Okay, I think okay, spelling is recommended, RECOMMEND. Okay, the we will recommended this product to these users based on this, because now the first thing is that must be fulfilled, this the product that we have to suggest, that must be a valuable product. First they have to check it must be a valuable product. It must be a valuable product. Must be a. So if we recommend some product that's not a valuable, so in such scenario it may be chance to lose our customer. So customer may be failed iterate some things. So it must be a condition that the product that is a similar product, that must be a valuable product. Then we recommend this product to that user. Okay, since the choice in the product for a valuable product, since its value is not changes so much after some initial period, so this will be the most key idea to use the item similarity. Okay, so the in generally the rule of thumb is the to choose a valuable product, the rule of thumb that we have seen here. Just I am just giving these examples through this picture. So the rule of thumb is to choose a valuable product. So more user more than items. Suppose let a situation. So suppose I am talking about the YouTube. If you consider the YouTube example, in the YouTube what happened? The number of users are more than the number of items. It is real. And also in Netflix, the number of users are mostly billions of users have in the Netflix, but the some millions of movies they are have. So in such scenario, if the number of users is much larger than number of items, is much larger than number of items, that is seen in by generally seen by Amazon's, YouTube, Netflix. That's that we have. It's general. It's a natural matter. Okay. So the item ratings that's matter. Item ratings are the matter. Okay. We have to the based on the item rating. Item rating means the item rating does not change much over time. That's the valuable item we can consider. So the items is the based on the item rating that does not change, does not change much over time, after some it's the conditions after some initial period, and every product has some, it's obvious every product has some initial period. After some periods its valuable must be decreased. Okay, if this thing happens, if some initial after some initial period people see that the rating of that product does not changed much, we can consider this is a valuable product after some initial period. If this thing happen, then we can consider it's a must be a valuable product. Okay, so these things, because of these things, it's item similarity. Because of these reasons, the item similarity is most popular among the among over all the similarity. So the item similarity is most popular. Because of these reasons, only because of the reasons, item similarities is most popular one. Since after some initial product, the product that we have picked after, if after some initial product its rating is not changed significantly, so then for this item we can consider as our recommended product. Means that it's a valuable product, must be it is a valuable product. But the user, for user cases, we see that the choice of the users are changed dramatically at over time. Okay, because choice of the users are depend on our needed, what is our needed, based on that we have make our choice. So it's significantly changed, it's dramatically changed over time. But the value for a valuable product, these things are is not changed so much. Okay, that's the main reason behind it to most important to take the item similarity as a most popular similarity based algorithm, because of only because of this reason. I think from these discussions you got the idea and how these two kind of similarity based recommendation systems are actually useful to build a recommendation system. Okay, and why these item similarity are most popular one among the user similarity. I think you got the idea, and how the mathematics behind it, how these comparisons techniques are actually work internally. I think you got the idea. Okay, I request you, if you have any problem, please comment it or mail me individually, so I will try to give you the more explanations as simple as possible. Okay, so in the next video we will see the matrix factorizations. So how to doing the matrix factorizations to solve these problems, means matrix competitions problem, competition. Okay, means matrix competition. Okay, problem. We'll see these things in next video.